Hello, students. This is Irshad. Welcome to class 9 ICS Physics. In our previous class, we discussed exercise 2C, motion in one dimension, covering questions 1 to 8. Today, we are going to continue with the questions 9 to 15 and understand each question step by step. So, keep your books and notebooks ready, stay focused, and let's make physics interesting. Let's start. Question number 9. A car travels a distance 100 meters with a constant acceleration and average velocity of 20 meters per second. The final velocity acquired by the car is 25 meters. Find the initial velocity and acceleration of the car. Let's see what is given first. This is the displacement. Yes, acquires the final velocity, so it is v equal to 25 meter per second, and average velocity is given 20 meter per second. Let's see to find the initial velocity first. Average velocity can be written as v average equal to u plus v by 2. This is the average velocity formula when body hours equal times 20 equal to u we don't know, but we know the final velocity, that is 25 divided by 2. Then 40 equal to u plus 25. U equal to 40 minus 25. Finally, the initial velocity of the car is 15 meter per second. Let's find the acceleration now. We know well acceleration can be written as a equal to v minus u by t. Final velocity 25, initial velocity 50 found. Then what is the time period here? Time period is not given. Then we do not use this equation. We will use kinematic third equation, like v square minus u square equal to 2as. We will use this. Then I will wipe it. So what is the final velocity here? 25. Then it is 25 square minus initial velocity 10 square equal to 2 into acceleration we don't know, so simply I have taken a, and displacement it is 100. 25 square is 625. 15 square 225 equal to 200. Get 400 equal to 200. Therefore, acceleration is 2 meter by second. Let's see the next one. When brakes are applied to a bus, the retardation produced is 25 centimeter per second square, and the bus takes 20 seconds to stop. Calculate the initial velocity of bus and the distance traveled by the bus during this time. Let's find what is given here one by one. So acceleration given here 25 meter by second square. This is the acceleration, and he said very clearly the body the bus come to the rest. So final velocity equal to 0. What is the time it has taken? It has taken the time is 20 seconds. 20 seconds. Then I will write it here to find the initial velocity of the body. I will use the kinematic first equation like v equal to u plus 80. Final velocity is 0. We don't know what is our initial velocity plus. So it is a retardation. Retardation. So a equal to minus 25 centimeter per second square. So I will write here 25 minus 25. What is the time? 20 seconds. Then 0 equal to u minus 500. Then u equal to 500 centimeter per second. Initial velocity in centimeter per second. Convert into meter per second. Then u equal to 5 meter per second. 5 meter per second. Okay, let's find what is the distance covered by the bus in this time period. I will use the kinematics second equation. That equation is S equal to ut plus half a t square. What is the S? We don't know. We have to find the S. S equal to u value we found 5. The time period is 20 minus 1 by 2 because it is a retardation. So I have taken minus. Acceleration is 0.5. I converted into SI system into time is 20 square. So S equal to what will you get? 520 is 100 minus 1 by 2 into 0.25 into 20 square 400. S equal to 100 minus shall I do the cancellation here? 1 ja 200 ja. Then we have 0.25 into 200. Then displacement equal to 100 minus 50. Therefore, displacement meters. So the bus covers last 20 seconds. See the question number. Next question. A body moves from rest. Given very clearly here, the body moves from rest. Then initial velocity of the body is 0 with the uniform acceleration and travels 270 meter in 3 seconds. Find the velocity of the body at 10 seconds after the start. The displacement given 270 meters and the time is 3 seconds. And need to find what is the velocity after 10 seconds. So before it, I have to find the acceleration. Acceleration I need to find out. I will use kinematic second equation, that is S equal to ut plus half at square. Displacement 270. Initial velocity 0. 0 into anything? 0. Plus 1 by 2 into a. What is the time? 3 squared. 270 equal to 9a by 2. 3 square the 9, so 9a by 2. Then you will get it here 540 mean you get 270 into 2 equal to 9a. 540 equal to 9a. Then a equal to a equal to 60 meter per second square. So this is the acceleration. With that the body can moves. And I have to find the velocity after 10 seconds. So I will use the kinematic first equation. Then v equal to q plus at. Final velocity v equal to initial velocity 0. Acceleration we found. See, the time is 10 seconds. So 10 seconds after we need to find the final velocity. V equal to 600 meter per second. So this is the final velocity after 10 seconds. A body moving with a constant acceleration travels the distances 3 meters and 8 meters respectively in 1 second and 2 seconds. Calculate the initial velocity and the acceleration. So in this question we do not know it what the initial velocity of the body. In the question he did not say the initial velocity of the body is 0 or something other number. So let us take the initial velocity u, and throughout the journey the acceleration is remain same. Have a look, it is I have taken a straight line and 3 points are donated a, b, the last one is a c. Let us take the velocity at a is u. A is a u. Throughout the journey acceleration is remain same. Acceleration remains same. This a it is. A to b has taken the time of 1 second. How much distance it covers? 3 meters. A to c, what is the time it has taken? 2 seconds. A to c. What is the distance from A to C? 8 meters. Let's take the kinematic second equation. S equal to ut plus half at square. First, I will take the case here A to B. When I will take A to B, A is the initial point and the B is the final point. Then it is 3 meters. A to B is the distance. U as it is U. The time is 1 plus 1 by 2. Acceleration A into 1 square. So we have 3 equal to U plus A by 2. Then 6 equal to 2U plus A. This is the first equation. I will take the case now A to C. A is the initial, C is the final. A to C time is 2 seconds. A to C the distance is 8 meters. So same equation 8 equal to time is 2, initial velocity U only, plus 1 by 2, acceleration remains same. So A time is now 2 square, time equal to 8 equal to 2U plus 1 by 2 into a 2 square 4, 2 1 ja 2 2 ja 8 equal to 2u plus 2a. I will take 2 common out from right hand side. 8 equal to 2 of u plus a. 2 1 ja 2 4 ja. So finally we have 4 equal to u plus a. Second equation. Solving equation 1 and 2, we get, so first equation is 6 equal to 2u plus a. The next equation is 4 equal to u plus a. Subtract, so this is the minus, minus and minus. Plus a minus a will get cancelled. 6 minus 4 is 2. 2u minus u. So initial velocity of the body is 2 meter by second. Initial velocity of the body is 2 meter per second. This u value, substitute any one of the equation, either 1 and 2. I will take from equation 2. From equation 2 it is 4 equal to, in place of u I will write 2 plus a. Then a equal to 4 minus 2. Then a equal to 2 meter by second. This is the acceleration with which body can accelerate. So let's see the next one. Question number 13. A car travels with a uniform velocity of 25 meter per second for 5 seconds. The brakes are applied, then and then the car is uniformly retarded and come to rest in further 10 seconds. Find the distance with which the car travels before the brakes are applied, the retardation, and the distance traveled by the car after applying the brakes. Let's see, let's write one by one what is given in the question. Okay, before it, there is a straight line. I will denote some points. The A point, B, C. A, B, C. So the here it is uniform velocity 25 meter per second for 5 seconds. Let us consider A to B has taken the time 5 seconds. I mean, at A point the velocity is 25 meter per second. At B point the velocity is 25 meter per second. Acceleration between the point A and B is 0. And velocities remain same. So I will write u equal to 25 per second by meter per second. And the next, further come to the rest. I mean, here the final velocity is 0. How much time taken from B to C? 10 seconds. 10 seconds. And this is the retardation. Let's find the acceleration first, with which the body can accelerate, solve it. A equal to, we'll take the case B to C, then B is the initial, C is the final. Acceleration A equal to P minus Q by T. A equal to initial velocity is 0 minus the final velocity is 25 time 10 seconds. A equal to minus 25 by 10. Therefore, A equal to minus 0.5 by second square. Finally, the acceleration. Let's see what is the distance traveled by the car with the uniform velocity or before apply the brakes. I mean A to B. A to B case. The velocity said here uniform, it is 25 meter per second. Uniform velocity, and it is said the time is 5 seconds. So formula directly we have speed equal to distance by time, then distance equal to, I will take here s1, speed into time. S1 equal to u value 25 into 5. S1 equal to 125 meters. 125 meters. Similarly, let's find the what is the distance covered by the body from B to C also. B to C. B to C case. B to C case. For this, we have final velocity minus initial velocity we have equal to 2as. Here we know the initial velocity and final velocity, uniform acceleration, I mean retardation. We don't know about the displacement. So final velocity is 0, 0 square. Initial velocity 25 whole square equal to 2 into acceleration is minus 2.5 into s, then minus 625 equal to minus 5 into s, and both side minus minus will get cancelled. Therefore, let us take it, this is the es2, es2 625 by 5, es2 equal to 125 meters. B to C, B to C also 125 meters. So till now we found the distance between A to B and B to C, uniform acceleration, uniform acceleration. So 3 we found. Question number 14. A spacecraft flying in a straight course with a velocity of 75 meter per second fires its a rocket motor for 6 seconds. At the end of this time, its speed is 120 kilometer per second in the same direction. Find the spacecraft average acceleration while the motor were firing. The distance traveled by the spacecraft in the first 10 seconds after the rocket motor were started. The motor having been in action for only 6 seconds. Only 6 seconds. Let's see what let us find what is given. This is the initial velocity 75 and the final velocity is 120. kilometer per second, and time is 6 seconds. Acceleration we will find. So acceleration equal to v minus u by t. A equal to, what is the u? V is 120, u is 75, time is 6 seconds. Therefore, A equal to 45 by 6. The unit you will get here, kilometer by second square. Kilometer by second. So there is a straight line. I will select 3 points A, B, the last one is a C. At A, velocity is u. At B, its velocity is v. And at A to B has taken the time is 6 seconds. A to C is 10 seconds. So what is the time between B to C? 4 seconds. Time is 4 seconds between C to C. Then first I would like to find the value of distance between A and B. I will take the case A to B here. A to B case. Then A is the initial, B is the final. I will use a kinematics second equation. S equal to ut plus half a t square. So this I will take as1 equal to u is 75. So 75 meter per second, time is 6 seconds, plus 1 by 2. Acceleration we found 40 by 3, right? 45 by 3. I mean, we can divide it. We'll get here 7.5 kilometer by second. So acceleration, what we'll write here, 7.5 into 6. Yes, 1 equal to. If we can multiply and add, we will get 585 kilometers. This is A to B. A to, and according to the given question, B to C, the body moves with the uniform velocity. The body moves with uniform velocity. Then at B point, the velocity is B to C. Velocity is 120. It is 120 kilometer per second, equal to s2 is our distance. It has taken the time 4 seconds. Then s2 equal to 12 4 ja 48. Then it is 480 kilometers. Therefore, the total distance between A to C is A to C. S equal to S1 plus S2. S equal to 585 plus 480. S equal to 1065 kilometer. 1065 kilometers. So once again, see what we have done here. A spacecraft flying in a straight course with a velocity of 75 kilometer per second fires its rocket motor for 6 seconds. At the end of this time, its speed is 120 kilometer per second, the same direction. Fine. The spacecraft average acceleration while motor were firing. The distance traveled by the spacecraft in the first 10 seconds after the rocket motor was started. The motor having been in action for only 6 seconds. I mean, the first 6 seconds, the motor moves with uniform acceleration, and remaining 4 seconds, the body moves with uniform velocity. 120, 75, 120 is a final velocity, 75 is the initial velocity. The time 6 seconds taken to change the velocity. Acceleration A equal to V minus U by T. Then I found A equal to 7.5 kilometer per second square. From the diagram, I have taken the case A to B and then B to C. Finally, I found A to C. So A to B case, kinematic second equation, S equal to ut plus half at square. Then I found 585 kilometer. B to C, uniform velocity. So speed equal distance by time. Distance equal to speed into time. That is 480 kilometers. A to C, I mean total distance. S equal to S1 plus S2. 585 plus 480. Therefore, the final answer is S equal to 1065 kilometers. Question number 15. A train starts from rest and accelerates uniformly at a rate of 2 meter per second square for 10 seconds. It then maintains a constant speed for 200 seconds. The brakes are then applied and the train is uniformly retarded and come to rest in 50 seconds. The maximum velocity reached the retardation in the last 50 seconds. The total distance traveled and the average velocity of the train. Let's see what is given in the question one by one. Train start from the rest. So what is the initial velocity of it? U equal to 0. U equal to 0. And it is for acceleration uniform A 2 meter per second square. It is for how much time? 3 seconds. Let's find the final velocity after 10 seconds. V equal to U plus 18. V equal to initial velocity 0, acceleration 2, time is 10. Then V equal to 20 meter per second. 20 meter per second. That is the velocity. After that, we need to find the retardation. Retardation. Second, 10 second after the body covers I mean certain distance with the same velocity or uniform velocity, uniform speed. So I will take x retardation need to find out. Then A equal to A equal to final velocity 0, initial velocity 20. What is the time? 3 seconds. Then A equal to minus 20 by 50. A equal to minus 2 by 5. A equal to Q by phi is nothing but minus 0.4 meter by second square. Acceleration. Acceleration. Let's see. Let's find out here. First, the body accelerated and uniform velocity. Finally, retardation. There are three cases here: acceleration, uniform velocity. The last is retardation. Then first, I would like to find x1 first. X1 equal to kinematic second equation ut plus half a t square. What is the x1? We don't know. So x1 equal to initial velocity 0 plus 1 by 2, acceleration given 2, and the time period is 10 seconds. 2 to get cancelled, 10 square. I mean x1 equal to 100 meters. And there is a case for 200 seconds. Time equal to 200 seconds. The body moves, the train moves with uniform speed. And what is the speed here? Is 20 meter by second. Let's find the x2 value here. What is the x2? x2 equal to v into t. x2 equal to 20 into 200. 20 200. Therefore, x2 equal to 4000 meters. Similarly, find x3. So it is a retardation like x3 equal to ut plus half a t square. Has taken the time 50 seconds. So 20 is a velocity, 50 is a time, plus 1 by 2. Acceleration we found 0.4 minus into 50 squared. x3 equal to 1000 minus 1 by 2 into 0.416 into 2005. x3 equal to 1000 minus 1 by 2 into 16 into 25. 1 ja x3 equal to 1000 minus 1000 minus 8 into 25. 8 into 25. 5. So there is a small mistake here. This is the acceleration now. It remains same, but I have taken the square here. It is 0.4. It is 0.4. I mean, I will write here 40. I will write 1 ja 220 ja it is. Then I will get 20 into 25. x3 equal to 1000 minus 500. Therefore, x3 equal to 500 kilometers. meters. What is the total distance? Therefore, the total distance x equal to x1 plus x2 plus x3. Then x equal to uh, first x1 is what? 100. 100 plus 4000 plus 500. So 100 plus 4000 plus 500. Then total distance covered by the train is 4600 meters. What is the total time? Total time equal to t equal to 10 plus 200 plus 50 seconds. I mean the total time is 260 seconds. Therefore, the average speed is v average total distance by total time taken 4600 by 260 unit you will get meter per second. 0 get cancelled. You divide, get 17.69 meter per second. This is our final problem. Please try to get it. We will come to the class for the next time with a new concept, with the new problems. Bye and take care of you.